A inverse is equal to 1 over the determinant of A multiplied by the adjoint of A. To understand why this works, I'm going to need three matrices. Matrix A, which is just some arbitrary matrix. I made it a 4x4. The cofactors of that matrix, and the adjoint of A. First thing I'm going to do is rearrange this formula. A inverse is equal to determinant of A multiplied by the adjoint of A. What I'm going to do is multiply both sides by A and by the determinant. So what this will do is get rid of this. It will turn this into 1, or the identity matrix, and the determinant of A over here will be canceled out, and it will be over here now, and then A will be here. So this is that formula rearranged. And before I get into this part, we need to very quickly go over finding the determinant by cofactors. So as we know, if we want to find the determinant of a matrix, we can use the cofactors and basically just multiply the entries by its cofactors. So to find the cofactor of A, what I can do is just multiply A11 times C11 plus A12 times C12, A13, C13, A14, C14, and that will give me the determinant. But a question is, what happens if I multiply this row by a different row, say C21, C22, C23, C24? And the answer to that is that it's always going to be 0. Anytime someone takes a row and multiplies it by a set of cofactors that is not that exact row, it's going to be 0. And it's the same deal with columns. If I take this third column and I multiply it by the first column, then the result's going to be 0. The second column, it's going to be 0. The third column, it will be the determinant. Fourth column, 0. So now that we got that out of the way, and why that is, I'll just explain it in some other section. I'll put a link there. But going on to here now, if we look at this rearranged formula and write it out, we've got A multiplied by the adjoint of A. So let's look more closely at what's going on here. We've got A, A11, A12, A13, A14, and then the adjoint of A, which is the matrix of cofactors transposed. You take this and turn it this way. So now C11, C12, C13, C14 is now C11, C21, C31, C41. This row is now this column. This column is now this row. They've changed spots. So when I multiply A by the adjoint of A, A11, A12, A13, A14 is going to be multiplied this row. Change the color. So with multiplication, we're multiplying row by column. So A11, C11, A12, C12, A13, C13, A14, C14. So what's going on in this first multiplication, since the adjoint is just this transpose, really what's going on is I'm getting this row multiplied by this row, because this row is actually this column and the adjoint. So the first entry is going to be the determinant of A, because we've got this row multiplied by this row. They're the same rows, so it's going to be the determinant. Now let's look at what happens at the second entry. So the second entry will be this first row times the second column. So A11, A12, A13, A14 multiplied by C21, C22, C23, C24. And looking back up here, this is not necessary, it's just easier to see. Since this is a transpose, it's multiplying this row by this row, the second one right here. I should probably draw a line through it or whatever. And as we discussed earlier, since it's not the first row, which would be the determinant, it's going to be 0. All the other multiplications, this row, this row, this row, they're all going to be 0. So that means this entry is going to be 0. And as we go along to the third row, fourth row, we can see how it's just going to keep being 0, 0, 0. So let's look at the second one. A21, A22, A23, A24. So multiplying to get the second row of entries, we go to the first column, C11, C12, C13, C14. So this times this is going to be 0, obviously. So put a 0 there. And then it's not until we get to the next entry, C21, C22, C23, C24, this column, that we're going to have this times this, which is the determinant. So you can see how the pattern is going to go. I'm either going to get the determinant or 0. And the spots I'm going to get in the determinant is where this row is going to be, if you think of the cofactors of A, it's going to be this times this, this times this, this times this, this times this. And where are those instances? Well, we've got here and here, here and here, here and here, here and here. And these are the matching entries to those multiplications. And if we look now, this is the determinant multiplied by the identity matrix. So you can think of it as just the determinant of A multiplied by the identity matrix. This is A times the adjoint of A, and this whole formula, as we showed in the beginning, is just this formula rearranged. So we can rearrange it back, divide by the determinant, and divide by A, and it will give the original formula